Hello Advanced Algebra 2 students, my name is Ms. Versailles and I am going to teach you how to convert between two quadratic forms. Here are all the quadratic forms that we have learned so far: vertex form, intercept form, and standard form. We have graphed in all of these forms the quadratic. Now we're going to move just into the equations and we're going to look at a standard form equation and we're going to convert it to intercept form. In order to go from standard form to intercept form, you're going to do a process called factor. We're going to factor standard forms. Our answer will be intercept forms or factored form. So tape in your notes from the sub and write in this goal for factoring: convert from standard to intercept form. So we'll start in standard form. You can see all the examples. Intercept form is the form with our two sets of parentheses, x minus p, x minus q. Sometimes there'll be an a value. So we have two different levels of factoring. First level is when a is 1. Notice all of your squared terms don't have an additional number in front of them. So when this happens, let's do example 1. A is 1. We want to look for two numbers that multiply to 6 and the same two numbers add to -5. So I'm going to make a list of numbers that multiply to -6. 1 and -6, -1 and 6, 2 and -3, -2 and 3. Those are the only pairings of numbers that multiply to -6. Now I have to decide which of these four pairings also adds up to -5. And that would be the first pairing. So my factors are n plus 1, n minus 6. To check your factors, all you have to do is convert this back to standard form. We convert back to standard form by double distributing. So check your work. Do it on the side. Check your work by double distributing. So n plus 1, n minus 6. We have n squared plus -6n plus 1n minus 6. Combine like terms, I get n squared minus 5n minus 6. I got the standard form back when I checked my answer. So that's how I know these are the correct factors of this standard form. I'm going to do one more level 1, and then I want you to pause the video and try the rest of these. So let's try this one. I'm going to look for two numbers that multiply to 8, and the same two numbers add to 9. So numbers that multiply to 8, 2 and 4. -2, -4, 1 and 8, -1, -8. Those are the only pairings of numbers that multiply to 8. And then I have to come up with which pairing adds up to 9, and that would be 1 and 8. So my factors are b plus 1, b plus 8. This is the factored or intercept form. And I'm going to do the same process to check my work. So there'll be a lot of double distributing here. B plus 1, B plus 8. When I convert back to standard form by multiplying, I get B squared plus 8B plus 1B plus 8. So that's B squared plus 9B plus 8. Check. Yay. So that means my answer, if I say factor this standard form, this is my answer, b plus 1, b plus 8. Now pause the video and try the rest of these level 1 quadratics. Welcome back. Hopefully you've checked your answers with the key provided by the substitute for level 1. Now let's move on to level 2. Level 2, in my mind, is when a is greater than 1. So I cannot just go straight into what multiplies to this. what adds to this, because I have an a value that is not 1. So when this happens, the first thing I try to do is try to find a GCF. So my first step is to identify a possible GCF. Meaning, is there a number that I can divide all of these terms by? And for number 1, there is. I can divide all of these terms by 2. So I'm going to do that. Divide by 2, divide by 2, divide by 2. So that leads me to 2 parentheses x squared divide by 2 plus 11x divide by 2 plus 24. I have to write the 2 here, because if I don't, then I don't have a 2. These are not equivalent expressions. Leaving the 2 there, if you distribute it back, now these whole expressions are equivalent. So you have to write that 2. Step 2 would be just factor it. So what's left over in parentheses sometimes can be factored further. And in this case, it can. So I have an a value of 1. I'm going to think of 2 numbers that multiply to 24, and the same 2 numbers add to 11. So if you still need to write out your whole list of numbers that multiply to 24, that's totally fine. I already know which 2 numbers multiply to 24 and add to 11. They're 8 and 3. So my factored form for 2x squared plus 22x plus 48 is 2 times the quantity x plus 8 times x plus 3. And just like we did with our other problems, we check our answer by double distributing. Check. These are equivalent forms. So when I double distribute and multiply out, I'm just going to multiply the 2 in first. I must get that original standard form back. So I get 2x squared plus 6x plus 16x plus 48. Combine like terms. 2x squared plus 22x plus 48, which was the original standard form. So this is my factored form, or my intercept form, of this standard form quadratic. Now sometimes step 1 can't happen, like in example 2. There is no GCF for all 3 of these terms. I cannot divide everything by 7. These are not divisible by 7, or 2, or 3. I can't divide by any number. When this happens, I set up my 2 factors with what I know must be true. If this first term is 7a squared, my first values must be 7a and a. Because when you double distribute, those are the only 2 values that give you 7a squared. So if this was 2a squared, I put 2a and a. 3a squared, 3a and a. But it's 7a squared, so that's 7a and a. And again, that's because when I double distribute, I'll get 7a squared. Now I just have to figure out what goes in the last 2 boxes, and I know for a fact they have to multiply to -5. So the numbers that multiply to -5 are 1 and -5, or -1 and +5. I also know that when I fill these in, I must, when I double distribute, get 34a. And 34a comes from multiplying the outside numbers and the inside numbers. Outside numbers and inside numbers, when I multiply those, has to add up to 34. So automatically I'm saying, oh my gosh, I know this has to be a 5. +5, because then I'll get 35, and when I subtract the 1a, I'll get the 34 that I'm looking for. So if you focus in on the outside numbers and the inside numbers equaling this middle term, you will be able to get your final factors. So I'm just going to continue distributing to check my answer. So it's 7a minus 1, a plus 5. Again, those outside and insides have to add up to the middle term. Let's try one more like this, and then I'll pause the video and you could spend the rest of your time completing level 2 and your homework. So one more. Number 3, another one where I cannot divide out a GCF. So I'm going to go right into 7R and R. Now I'm going to come up with my values that multiply to C, multiply to the last term. So that would be 1 and -9, -1 and 9, 3 and -3. Or those could be reversed, right? -3 and 3. So I know now the outside and the inside have to add up to -2. So I'm going to start trying certain things here. If I put -9 over here, -9 times 7 is -63. That is way too far away from -2. If I put -1 here, multiplying by 7, that's -7. Ooh. If I put -1 here, plus 9, but -7 plus 9 is +2, so I'm getting closer. Now I know I'm going to be putting +1 here, because I get 7. And the inside, +1 and -9, when I double distribute, I will get the standard form back. So you always look for the outside and the inside have to add up to that middle term. Double check your answer, make sure you got it. 7R minus 9 times R plus 1, 7R squared plus 7R minus 9R minus 9. So 7R squared minus 2R minus 9, and I got it. So these are the factors of 7R squared minus 2R minus 9. Do not copy. I'm going to write that down here. Do not copy. Factoring is something that you have to practice. You have to build your number sense in order to master. This skill is going to take us into Unit 3 and Unit 4 and next semester in Units 5 and Unit 6. So do not copy these. Please, please, please. Try the problems, check your answer key with the sub, and then for the last 5 or 10 minutes of class, you'll be able to start your homework, which is page 8 tonight, page 8. Ask each other questions, send me a remind, ask the sub, she used to be my student, and have a great day. Goodbye.